Hello, Geometry. This lesson is titled Classifying Quadrilaterals. Well, first let's remember that a quadrilateral is a four-sided polygon. So again, quad, obviously, meaning four. And so a quadrilateral is a four-sided polygon. Well, there's different types of quadrilaterals, and that's what we're going to be going over. So here we have some specific characteristics of quadrilaterals. What do you call a quadrilateral that has two pairs of parallel sides? Now let's say that's all you know about it is that there's two pairs of parallel sides. Well, we call that one a parallelogram. Okay? So two sides is called a parallelogram. One pair of parallel sides is what we call a trapezoid. Okay? And then if you have no pairs of parallel sides, but two pairs of congruent sides, what we call that is a kite. Now, what do each of these look like? A parallelogram basically is going to look something like this. Okay? Now, we said opposite sides are parallel. Now, the symbol we use for parallel is going to be arrows. Okay? And since we have two pairs, we have to do two sets of parallel sides there. Here for the trapezoid, what we have looking like this, in which, again, only one pair of parallel sides. And lastly, we have the kite that we talked about, in which opposite sides are going to be two pairs of congruent sides, but the opposite sides are not parallel. So that means these two sides will be congruent, and these two sides will be congruent, and there's no parallel sides. Now, with the kite and the trapezoid, that's pretty much it. But with the parallelogram, there's actually different types of parallelograms as well. So a parallelogram is a quadrilateral, but we're going to get even more specific with these two. So we're going to branch off here. What if the parallelogram, if all four angles are right angles? Well, in that case, we call that one a rectangle. Okay? Now, what if the parallelogram has all four sides, but we don't know about the angles? All we know is that it's a parallelogram and there are four congruent sides. The name for that is a rhombus. Now, what do these look like? I'm sure you're very familiar with the rectangle. Here you have, again, you have parallel sides, two pairs of parallel sides, but the thing about a rectangle is that you have right angles. All four angles are right angles. Now, a rhombus, again, we don't necessarily know the degree measures of the angles. All we know is that you have all sides are congruent. So it's basically, another name for it is a diamond, okay, in which it is a parallelogram, but all four of the sides will be congruent, okay? And lastly, what happens if you have a rectangle? So what happens if you have a parallelogram that has four right angles and has four congruent sides? Well, that's where we come up with the square. Okay? So a square, as we should all know, it has four right angles. Pardon the drawing here. And all four sides are congruent. Okay? So if you think about it, a square is a rhombus and it is a rectangle. Therefore, it is also a parallelogram, which is a quadrilateral. Okay? Now notice, not every rectangle is going to be a square, but every square, by definition, is going to be a rectangle, and every square, by definition, is a rhombus, but not vice versa. Okay? And all three of these, so the rhombus, the rectangle, and the square, are all types of parallelograms. Okay? Alright, now let's move on. Now, judging by their appearance, I have two pictures here. We need to classify these quadrilaterals in as many ways as possible, but we have to go off what we know. I know it says judging by their appearance, but we're still going to go off factual things. So appearance with their markings. So the first thing we see here, this first one, WXYZ, is we know it's four sides, so we know it's quadrilateral, but we also see that we have four congruent sides. So therefore we can conclude for sure that it's a rhombus. And since it's a rhombus, it has to be a parallelogram as well. Because if it is a rhombus, it has to be a parallelogram. Now, just because four sides congruent, don't automatically write the word square, because, again, that's a mistake a lot of people make, is they just see congruent symbols. They don't think logically. These are obviously not right angles in W, X, Y, Z. So it's a rhombus, which is also a parallelogram. Now, this next one, on the right, now it looks like a square. I will agree with you. Now, technically, there are not markings to for sure say that the sides are congruent. So therefore, we can't technically call this a square. We have to have that marked out for us to for sure say it's a square. So yes, it does look like a square, but all we know for sure is that we have four right angles. So therefore, we know it has to be a rectangle. And again, like the other one where we said, since it's a rhombus, it's a parallelogram. Same thing with the rectangle. If it's a rectangle, then it has to be a parallelogram as well. Okay? Alright, let's move on to the next page. Next problem here. Determine the most precise name for this quadrilateral, LM and P. So we have to classify this quadrilateral. Is it just a parallelogram, or is it a parallelogram? Is it a parallelogram and a rhombus? What do we have going on here? So, well, the things that we talked about, for it to be a parallelogram, we have to know that the opposite sides are parallel. Well, opposite sides are parallel. When we're actually dealing with some coordinate geometry, the way you can tell is if opposite sides have the same slope. So that's what we're looking for. Same slope. Do they have the same slope? Again, that's what we're looking for. Okay, now the question is, how do you find slope? Well, don't forget the slope formula is m is equal to y2 minus y1 over x2 minus x1. M meaning the slope. So we're going to pick 2 points and we're going to find the slope. So let's find the slope first of LM, okay? We're going to find this orange slope first. So I'm going to take the y value of the m, subtract it from the y value, subtract the y value of L, so therefore 2, over the x value of m minus the x value of L. So that gives us 1 over 2. Now what we want to see is the other side, NP. We'll do a different color here. We'll do blue. NP. If they end up with the same exact slope, then we for sure know that those opposite sides are going to be parallel, and then we'll check the other two. So we take the y value of n minus the y value of p over the x value of n minus the x value of p. So therefore that gives us 1 over 2. So we know that these two slopes are the same. Therefore we can conclude that these two sides are parallel. What we want to find out is, are the other two sides parallel as well? Because if they're not, then we're dealing with a trapezoid. But if they are, then we know that it's a parallelogram. So let's look at this one first. We'll do that one in yellow. Oops. Okay, we'll do this one in yellow, MN. So, y value of m minus the y value of n over x value of m minus x value of n. So that gives us 1 over negative 2. So we have negative 1/2. So our final one we'll do, let's do dark color here. We have LP. So we'll do y value of 2. Oh, that's a little too dark. I'll do that one in, let's switch this color. We'll go with green. So we'll do a green one here. So we have y value of 2 minus y value of p over x value, I said y value of 2. Sorry, y value of L minus y value of p over x value of L minus the x value of p, which is 1 over negative 2. So again, notice these end up the exact same. So therefore, those two sides are parallel to each other. So we know for sure right now that it's a parallelogram. We can determine right now that we're dealing with at least a parallelogram. I'm running out of room. I'll just type it out. Alright. There we go. So, we have parallelogram. Now what we have to find out is, do we know, or can we prove if this is a rhombus or not? Because these obviously, we can say for sure just by looking at this, these are not right angles. We know that for a fact just by looking at it. So the only other option is, could it be possibly a rhombus? Well, the way we find that is to look for the distance. There we go. Now we're looking for distance. So I'm going to go ahead and make some room here. So I will erase all of this stuff. And now we're going to do the distance formula. What is the distance formula? The distance formula, in this case, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we could find all those distances, again, if they end up all the same, then we know for sure that it's not just a parallelogram. It's not just a parallelogram, but it's also going to be a rhombus. Okay? So let's do that. So what we're going to do, let's just go ahead, we're going to find the distance of LM first. Stylus is wigging out on me. LM. Again, we'll do the x value. Pick one of the x values, subtract the other. Okay, squared. Plus the y value minus the other y value squared. And again, we have the root over the whole thing. So that gives us 3 minus 1, which is 2 squared, plus 3 minus 2, which is 1 squared. And then that gives us 4 plus 1, which gives us the square root of 5. So we know that this distance here is the square root of 5. Alright, now let's find the next one. I know it's kind of a long problem, but all of it is doable. Just take it one step at a time. Okay, so again, we found slope first of all of them. Now we're going to find the distance of each. So let's go, we'll do this one in blue. Okay, so we're going to find the slope of MN now. So we do an x value minus the other x value of the two coordinates, plus we have a y value minus the other y value. And again, we're going to take the square root of that whole thing. So that gives us negative 2 squared plus 1 squared. Now the thing I want you to watch out for, because a lot of people make this mistake, is that when they square the negative, they leave it as a negative. Remember, that's a positive. So that's 4 plus 1, which is root 5. So here we have the square root of 5. But that's 2 already. And let's find the third one. Okay, do that one in orange. Let's do NP. Okay, let me go ahead and erase this. Okay, so we have NP. So we have x minus the other x value. We're going to square those, plus the y value minus the other y value squared. Alright, that gives us 2 squared plus 1 squared, the square root of both of those, which is 4 plus 1, which is the square root of 5. Alright. Now I will tell you that if you have a quadrilateral and you have 3 of them that are going to be the same length and opposite sides are parallel, 2 pairs of parallel sides, that fourth one will be the same as well. So notice we have all 4 sides are going to be congruent here. So in this case, this is not just a parallelogram, but also a rhombus. Alright. So I know that takes quite a few steps, but the more you do these, the easier it becomes. So the 2 things we're looking for are opposite sides parallel, and our opposite sides are all sides, how many of them are going to be congruent to each other? Okay, so that's what's going to help us determine that. Alright, I do want to make one little statement about this, about the angles. When we were dealing with slope, if you're working out the slope and the two connecting sides, their slopes are negative reciprocals of each other. Let's say hypothetically the slope of LM, again the slope, was 1/2, and the slope of MN was -2. Notice these are negative reciprocals from each other. If that's the case, then at M would be a right angle. So that's a way to tell if you're dealing with right angles or not. Okay, so again, they have to be negative reciprocals of each other for them to be a right angle, because that means these would be perpendicular to each other. So that was a little side note, just wanted to let you know. Alright, let's do the next problem. Here we have now a kite. Okay, again, the thing about the kite are the two sides that are, we have two pairs of congruent sides. That's the thing you have to keep in mind with a kite. So these two sides will be congruent to each other, and these two sides will be congruent to each other. So therefore, we just set their variables, we set their values equal to each other. Now, if you look at the top two, if we were to set these two equal to each other, you would have an equation in which you have two variables, because you have 2y plus 5 is equal to x plus 6. We can't really solve it if there's x and a y, so what I would do is look to the bottom two. Now we do know that the bottom two, we have 2x plus 4 is equal to 3x minus 5. Well, here we have one variable, so we can solve for x. So we would subtract 2x, we move that over to cancel that out. So that leaves us with 4 is equal to 1x minus 5. And then we add the 5 over. So therefore, x would equal 9. Now the fact that we know that x is equal to 9, we can go back up here to the top, change colors here, and we can plug the 9 in there. So we have 2y plus 5 is equal to 9 plus 6, which 9 plus 6 is 15. Whoops, sorry. So we have 2y plus 5 is equal to 15. So we're going to subtract the 5, just doing regular algebra steps from here, algebraic steps. So we have 2y is equal to 10, divide by 2, divide by 2, we have y is equal to 5. Again, that's a 10. So there goes our two answers right there, if we're looking for those variables. Now notice, you always want to finish reading the question here. It says, then find the lengths of the sides. So, if we go ahead and plug these values in, this is a great way to check your work too, is to plug back in. So, we know that y is 5, so let's find JT first. So 2 times 5 is 10, plus 5 is 15. If we plug into TK, did I do that wrong? Sorry. If we plug that in to TK, we should get the same thing. Now notice it says x is 9, so 9 plus 6 is 15, so we can be assured that we did this correctly. Now JB, x, so 2 times x, so 2 times 9 is 18 plus 4 is 22. Lastly, we plug this one in. 9 times 3 is 27, minus 5 is 22. There you go. So we can be assured that we did it correctly. So always check your work. Alright. And here we go. This will be our last problem here. It says find the values of the variables for the rhombus. Again, you always want to look for keywords here. In this case, it's rhombus. Then find the lengths of the sides. So what do we know about a rhombus? We know that all four sides are the same length. So therefore, not only are all four sides the same length, but that means opposite sides are. So if we want to find A, we know that the opposite sides are congruent. So we can say 5A plus 4 is equal to 3A plus 8. So we subtract the 3a. Again, this is just a matter of getting variables to one side. So that gives us 2a plus 4 is equal to 8. Then we subtract the 4, Cancel that out. So we have 2a is equal to 4. A has to be 2. Okay? Now we do the other two sides to find for b. So we know that 3b, oh, I need to give myself some room here. I'll go ahead. Just move that really quick. So we have 3b plus 2 is equal to 4b minus 2. So I'm going to go ahead and subtract 3b from both sides because I want to get, again, the b's to one side. So that gives me 2 is equal to 1b minus 2. Therefore, I add this 2 over. B has to equal 4. Now, the best way to know if you did it right is to check your work. And anyways, it does say find the lengths of the sides. So if we plug in 2 for A, we'll find SL. 5 times 2 is 10 plus 4 is 14. Let's go to the other side. 3 times 2 is 6 plus 8, which is 14. Now if we did B correctly, we should get 14 over here as well. 4 times 4 is 16 minus 2, gives us 14. And up top we have 3 times 4, which is 12, plus 2 is 14. So we can be assured that we did this correctly. So again, the key thing, the thing is you want to look for that key word that will help you on these problems. So here it was rhombus, so we knew opposites, or all the sides are going to be congruent. Here, up here, we saw the word kite, so we knew that the two shorter sides will be congruent to each other, the two longer sides will be congruent to each other. Okay? So again, these are the different types of quadrilaterals that we're going to be dealing with. I definitely hope this helps. So, good luck.